This section of the notes is a review of how to find vertical and horizontal asymptotes and then how to write the limit notation that corresponds to these asymptotes. I felt this was important because this is a big part of this section, and as you are well aware, writing limits correctly is a big part of this course. So I've given you 3 different rational functions. We're going to find the vertical and horizontal asymptotes in part 1. And in part 2, we're going to write the limit notation. So starting with letter A, let's find the vertical asymptote. And we do that by finding what makes the denominator undefined. So we'll set the denominator equal to 0. And when we set x minus 1 equal to 0, we get a vertical asymptote of x equals 1. Now finding the horizontal asymptote is a process of looking at the degrees of the 2 polynomials of the numerator and denominator. In the numerator, we have -3, which has degree 0, and in the denominator, we have a linear function, which is degree 1. Since the degree of the denominator is greater than the numerator, the horizontal asymptote is going to be y equals 0. So now to write the limit notation for those, we are going to start with the vertical asymptote, and we're going to write one limit for the left of the asymptote and one for the right. So let's set that up and I'll show you how we find this without looking at the graph. So we're going to take the limit as x approaches 1, and then we put a little minus up here for the left of f of x. And then we're going to write the limit as x approaches 1 from the right, and we put a little plus there of f of x. Now, how we find those is a real simple process, and we can do it in any calculator. So let me pull calculator up here. So what I did, if you look at the one in blue, I picked a number to the left of 1, but very close, 0.99. I substituted that in the function. And when I did that, I got a positive 300, kind of a large positive number. And then right below that, I put in for x 1.01, which is just to the right of 1, our vertical asymptote. And if you notice, the value was negative 300. So I have a large positive number when I'm to the left, and I have a larger negative number when I'm to the right. So that means when we're going from the left-hand side, what we get is that the function is headed towards infinity. And from the right-hand side, since that number was negative 300, we're headed towards negative infinity. Now, the horizontal asymptote, just to remind you, is the end behavior for very, very large and very, very small x's. So the limit as x approaches, and we can write this in one limit, the limit as x approaches negative and positive infinity, so we can write positive or negative infinity because it's for very large and very small x's of f of x is going to be the value of our horizontal asymptote, which is 0. Okay, so now let's do part B. So in part B, our horizontal asymptote is going to be a little different than what we found in part A. But let's start with the vertical. And again, for the vertical, we're going to set the denominator equal to 0. And when we do that, x plus 4 equals 0. We get a vertical asymptote of negative 4. So then the horizontal is going to be, again, the ratio of the leading coefficients. Oh, not again, but a ratio of leading coefficients, because both of these polynomials are degree 1. We have a minus 2x as the leading term in the numerator, and a positive 1x as the leading term in the denominator. So our horizontal asymptote is going to be that negative 2 over negative 1. So it's going to be y equals negative 2. So again, for the vertical, we're going to have to look to the left and right of negative 4 to see how the function breaks. So to the left, let's set it up and then we'll look in our calculator again. We have the limit as x approaches negative 4 to the left of f of x. And then we're going to have the limit as x approaches -4 from the right of f of x. And I did the same procedure in the calculator I did before. I picked a value just to the left of -4, which was -4.01. I substituted in the function and I got -1302, and then, which is a large negative number. And then I was just to the right of -4, so I substituted in -3.99 in for x, and I got positive 1298, so kind of a large positive number. So that's going to tell me which direction my limits are headed. So the limit as x approaches -4 from the left-hand side is going to be -infinity, and the limit as x approaches -4 from the right-hand side is going to be positive infinity. Now, the only other limit I have to write is the one for the end behavior, and we have a horizontal asymptote of -2. So the limit as x approaches positive and negative infinity. Remember, the horizontals for very large and very small x values, and it heads to our horizontal asymptote of -2. Okay, so we have one more to do, and this one is definitely a little different because now we have a quadratic function in the denominator. So the best way to start this one is to first factor anything that can be factored and cancel out common factors, because especially for the vertical asymptotes, they are going to be holes in the graph, the factors that are canceled out, and not vertical asymptotes. So x squared minus x minus 6 factors into x minus 2, x plus 2 times x minus 3. So the x minus 3's will cancel. And that leaves us with only one vertical asymptote. So we are only going to set x plus 2 equal to 0, and we get x equals -2. Then for the horizontal, we want to look again in the original function, the degrees of the two polynomials. So in the numerator, x minus 3 is degree 1, and x squared minus x minus 6 is degree 2. So the degree in the denominator is greater than the degree in the numerator. So we're going to have the horizontal asymptote of y equals 0. So now, as before, we're going to look on the left and right side of the asymptotes to find whether the vertical is going to positive or negative infinity. So the limit as x approaches -2 from the left of f of x, and then the limit as x approaches -2 from the right of f of x. And I did the same thing I did before. I'm not going to show you in the calculator, but I put -2.01 in, and I got a negative number. So that is headed to -infinity. And then I put -1.99 in the calculator because that's a little to the right of -2. And I got a positive number. So that means the limit as we approach -2 from the right is going to be positive infinity. And then finally, our horizontal asymptote is our end behavior. So as x approaches positive or negative infinity of f of x, it's going to approach our horizontal asymptote of 0.